So good morning once again. Let me share my screen first. Who is this Ragam Hasini and Anirudh? Add you in roll numbers, ma. Fine. In continuation to the previous class, let us solve some more problems related to theorems. By end of the class, I will share the notes, some PDF related to network theorems, just like which I gave for unit 1 as well. Fine. So, everyone there? Shall we solve some problems on superposition theorem? Fine. Okay. So note on this question, using superposition theorem, find the current in each branch of the network shown in the figure below. Is my screen visible? Rule number 12, is my screen visible? Yeah, good. So note on this question, let us solve for this. A star connected source with a star connected load, right? And you are given with some directions of currents here, I1, I2, I3. Fine. So you just mark them as they are and use the superposition theorem and get me the values for I1, I2, I3. You can may the procedure may be lengthy, but it will take less few time. Say the steps will be very easy, right? Here, Iman. Number 12, 13, 44. Did you take the question down? Okay. Take it and solve it. So what's the can you tell me what's the procedure we need to follow first for superposition theorem?
Short circuit both voltage source.
Yeah.
Short circuit in the voltage sources.
Yeah, since you have all the, how many sources we have in the circuit? We have 3 sources in the circuit. So namely 20, 30 and 40, right? So what has to be done for while applying superposition theorem? The procedure for applying superposition theorem is that we assume one source acting alone and the other sources are replaced with their internal resistances. So since these are voltage sources we have, we replace them with a short circuit, right? So when you consider, say, considers only first case, we can consider that this voltage source 30 and 40 to be shorted, right? Just like this, isn't it? So now you can write the equations for these currents. Now, since we assume that the total currents to be, when three sources are acting, the currents we assumed is to be I1, I2, I3. But in the case one, when we are assuming only one source, we can assume the currents to be 1 dash, I1 dash, I2 dash, and I3 dash. So now you find the values of I1 dash, I2 dash, I3 dash when you have only one source acting. Tell me the values for I1 dash, I2 dash, and I3 dash. Will you be able to find those values? Yeah. Give a good try. First thing to know is to find the value of total resistance, right? To find the value of, at least to know the value of total current, right? How to get the value of total current? If you find the total resistance, right? So how what is the total value of total resistance now?
Total current is equal to 0.923 amperes.
0.923 amperes. That is I1 dash, right? See, if you consider this this circuit, right? It doesn't, since we are shorting here the sources here, we have replaced the sources with some short circuit here, right? So it doesn't make any difference even if I join these two like this, or if I consider these to be a short circuit, right? That means these two terminals are one and same up to here, right? All these lines, these both lines are one and same, right? So you can simply draw the circuit with these two elements, right? So what is the circuit you can draw? You can draw this to be resistor with some parallel resistance in this circuit, right? You just join them across this voltage source, right? Is that okay? Is it, are these two on equal? Can I draw this circuit like this? Yes or no?
Sure, got
This value is 15. This value is 10. Right? And this value is 20. Yeah, you can use it, right? Now you can find the equivalent resistance. What is the equivalent resistance could be?
65/3.
Yeah, 10 and 20 are in parallel in series with 15. What's the value you get here? 15 plus 200 by 30. 200 by 30, you're going to get it as 6.667. So you'll get it as 21.6 67.
What is the value? I1 is equal to 0.
What is the value of R?
I2 is equal to 1.5. I1 is equal to 0.575. And is equal to 1.
21.66.
Yeah, 21.67 ohms is the total resistance. So what's the value of current gonna be? What is the total current that's?
Total current equal to 0.923.
Yeah, it is nothing but I1 dash is equal to 20 divided by 21.67. We'll get it as 0.9. What's the value you're going to get?
I1 dash equal to 0.639 amperes.
What is the total current?
0.923 amperes.
0.923, right? So what? How does it make 923, right? So how does it make a difference between I1 dash and total current? What is total current now? I1 dash or I2 dash or I3 dash? The total current is what which comes
The
from the
I1
source, right?
dash.
So it's just like I1 dash, right? So this is the total current now. So now that current is going to divide into two terms. What is that? I2 dash and I3 dash. So calculate the value of I2 dash and I3 dash. Apply the current division rule. You can get it right. Divide this into three parts. One part, two parts flows through 10 ohms and one part flows through 20 ohms. What's the value of current you get? 0. What's the value you're going to get as I2 dash? 0.307 approximately.
Yes, sir.
Is that okay? And what's the current that flows in the 10 ohms? I3 dash will be equal to the rest of the current 0.62 approximately. So tell me the values. So
0.616.
0.153 amperes. I2 dash equals to 0.6153 amperes.
yeah. So I1 dash, the total current is given as 0.923 amperes and I2 dash as 0.307 and I3 dash as 0.616. Fine. Is that okay?
Yes, sir.
Fine. What's the second case we consider? We can consider one of another source here. Could be something like this. So you can assume second source as case 2 as where only for 40 volt source is acting. So repeat the same procedure and get me the values of I1 dash, I2 dash, I1 double dash, I2 double dash, and I3 double dash.
What is DCP? DCP is nothing but what is the flow, right? Minus DC. What is the flow? So this is the way to find the these forces. Solve this three. What is the flow? Minus. Another we know 12 to 0 back.
What is the current you are going to get?
I will also find how to break it. KVL equation for this.
Tell me the values for I1 double dash, I2 double dash, and I3 double dash. See, the directions are what we keep there, right? It's up to you whether you take the directions in this specified way or not.
I3 double dash equals to 1.538 amperes.
Yeah, I1 double dash is
I3 double dash.
okay. So this will become the total current now, right? According to our assumption, this will be the total current, which will be divided into I1 dash and I2 dash. So what's the total current?
1.538.
Yeah.
Here we have considered AB.
अगर आप यूज कर रहे हैं
But the question is same. Just apply the KVL. Based on the polarity
So
of the
what is the resistance you are going to take equivalent as? Now these two will be in parallel, right? Remember, what say resistance is 15 and 20 ohms will be in parallel. That will be in series with 10 ohms, right?
right?
Yes, sir.
Are the equations okay?
Apply KVL.
Yes, sir.
Yeah. So what's the total? Total resistance across source.
You got the same answer. This one. For the yes, for the loop ABC also you are getting the same value now.
Is the values okay?
Yes, you will get the same.
Okay, done.
Yes.
Fine. So you got the values for I1 dash, I2 dash, I3 dash, and remember the directions of the currents which you are taking here, right? Because since we assume that source is present in this leg, then the current will be delivered from this and will be divided into these two. So that's the reason why we assume this direction, which are not same as previous case, right? The current of I3 dash is opposite to that of I3 double dash. So you just remember them while solving the total currents, right? So we finish case 1 and case 2 when two sources are acting separately, and we are left with third case. What is that? Third case when we have 30 volts acting alone. So calculate the values of currents for this. What is the value of I2 triple dash? Now what is the equivalent resistance will be?
I2 double triple.
Yeah, I2 triple dash is the total current. What is the equivalent resistance?
Deactivate the source. Check whether the sources are deactivated.
46 ohms.
Yeah, which two are in parallel?
10 and 15 ohms.
Yeah, 10 and 15 ohms are in parallel. That is in series with 20 ohms. That is the equivalent resistance will be 20 plus 10 parallel with 15. So you get it as 26. What is the value? 26 ohms, huh?
Yes, sir.
150 by 25, you get a 6. Okay, 26 ohms. So what the total current could be? I2 triple dash is equal to 30 by 26. What is the value you are going to get? The total current you are going to get is 1.153. So you can divide the currents now as current in 15 ohms. You can write as I1 triple dash. Current in 10 ohms. You can write as I3 double dash. So what is the total current? What are the currents you are going to get? 0.461 amperes, 0.692 amperes. Is that by are the values okay?
Yes, sir.
Fine. So now we have three cases and the values of three currents. That is each source. We calculate the values of currents in each branch when each source is acting alone. So what should be done when for the conclusion of superposition theorem? What is the conclusion? What is the statement for superposition theorem? The response or the current through any individual any element can be given as the algebraic sum of responses when each source is acting alone, right? So we need to make an algebraic sum of all these currents based on their directions such that to get the value of currents which was asked in the question, right? What was asked? What is the current magnitude of current in this direction? I1, I2, I3, right? So let us see how you get these values. So we already got the values of three currents. So what is the conclusion we can make? What is the total current for I1? We took it as I1 dash minus I1 double dash minus I1 triple dash. What is the reason why did I take minus? Since I said it should be a algebraic addition, right? Algebraic sum. So when
Opposite direction.
yeah, see the directions of currents in in all the three cases. In the first case, only the current is flowing from left to right. In second case, it is reverse to the first case, as well as in the third case, it is reverse. So that's the reason why we consider it as I minus of these two. right? So what's the total current you are going to get is this value, right? So 0.923 is the current which was flowing in the first case. Minus 1.23 is another current, and minus 0.461 is another current in third case here, right? So what is the resultant current I am going to get is minus 0.768. What does it indicate if we get it as minus 0.768? The direction of current which was given in the problem is opposite to that of actual flow of current. Note on the values for I2 and I3 similarly. Make a note that the negative signs with I1, I2, I3 show that their actual directions are opposite to that assumed. Is that okay? Now, what is the equivalent here? Any doubts regarding this problem? You can expect these type of problems in your exams because they are lengthy. They are easy, but they are lengthy, right?
Sir, in the last case,
Yeah.
how is 15 parallel to 10, sir?
Yeah. In 15 parallel to 10. See.
Confusing, sir.
No need to get confused. Just see what happens if I push this this branch over this. Can I draw it something like this?
Folding, you're saying.
Yeah. Folding this.
Folding.
If I can remove this, what is the other way to draw? Can I draw it something like this? If this is not
Okay.
if this is not
Yes.
allowed,
Yes, sir.
just shorting, right?
Yes, sir. Yes.
Yeah, so that will be clear. And
Yeah.
don't see, this is a symmetrical circuit. You can apply the same principle what you have done for first case. What is the assumptions we made in the case one will be applicable for all the three cases, right?
Okay, sir.
So now this is how we calculate the values of currents using a superposition theorem for a star connected network. Is that okay with the circuit and problem? Shall we move on to the next one? What is the value of load resistor? Yeah. What about others? Is everyone present there?
Yes, sir.
Yes, sir.
Yeah, I see 54 participants. Yeah, but only few are responding. What about others? Ganesh, Archana, Vamshi. Any doubt? Yeah, let us move on to the next problem. Yeah, is the screen visible? Example 2. Find the Norton's equivalent circuit at terminals XY in the figure below. Is the circuit visible?
Yes, sir.
Yes, sir.
Yeah. Try to find a Norton's equivalent circuit. See, I have mentioned one method here, but no need to follow that. You just follow the procedure which we followed for finding the equivalent circuit. So in a Norton's theorem, what is the equivalent circuit of Norton's? What is the representation for Norton's equivalent circuit? What are the elements you have find in a Norton's equivalent circuit?
IN and RN.
IN and RT.
Yeah, you want a practical current source there, right? So how do you find IN and how do you find RN?
We can convert the voltage source into current source.
Okay, it's up to you whether how to solve the problem, right? So now, if at all you want to find RTH or RN, it's simple as RTH, right? So what should be done first for finding RN or RTH?
The independent
Current
sources should be removed.
voltage
Yeah.
sources should be shorted.
The sources 30 volts and 18 volts, you can short them, right? So you just short these sources and consider that the current is flowing from into the circuit like this. That is, the current is getting divided. So these two are said to be in parallel, right? So find the equivalent of resistance 10 parallel with 20. What's the value you get?
6.6.
6.6.
Yeah, 6.67 ohms, right? You got the value of Rn. Then how do you get the value of In then? What's the principal procedure for finding In? What is In actually? Is the short circuit current across the terminals XY, right? Yes or no?
Sir, we can short the XY and then we can find current
Yeah,
through
that's
each
what I.
branch and then add them.
Yeah, whatever the procedure you can follow and get me the value of In. Get me the value of In. What's the value you get for In?
Sir, 3.3 amperes.
How did you come to that value? How did you calculate?
I used normal KVL, sir. I applied it for loop 1 with 30 volts and then with loop 2 with 18 volts.
Yeah, okay. What is the loop 1 equation is 30 minus 20 I1.
Yes, sir. Minus 20 I1. Yes, sir. Is equal to 0.
Okay. Loop
And
2.
then 18 minus 10 I2 is equal to 0.
Okay.
Then I added I1 and I2, sir.
Hmm.
Then IN is the current flowing through X and Y. So the current due to 30 volts, current due to 80 volts.
Okay.
So I got 3 points.
Okay. So let us do some verification for that. Let us not rush to conclusion now for that. Okay. I'm not saying that the procedure you followed is wrong, right? But I want sorry. One second.
So we should subtract the both currents we got in loops, no, sir. They're in opposite directions.
Which currents? It depends
The
on
loop currents are in KVL.
no. It depends on how you assume that how the currents are assumed, right? Isn't it?
Yes, sir. Yes.
Yeah. One second. Please. My screen is not rolling. Okay, fine. So what's the current you got? Let us. What's the value of current you got?
3.33 only, sir. I also got.
Yeah,
Yes, sir.
3.3. And what's the equivalent resistance we got is
6.67.
6.6.
I think it will be 0.3, sir, because he said is correct, sir. They are in opposite directions.
No. They are not in opposite directions. The equivalent current is 3.3 amperes and the
Yes,
resistance.
sir. Even if we take in opposite directions, the signs will compensate, sir.
Yeah, if the see the voltage source is opposite to that, so you definitely get the same way.
Oh, yes, sir. Yes, sir. Yes.
The value
yes.
remains same,
Okay,
right?
okay.
Instead of writing voltage drop in negative and voltage source in positive, you write in reverse. That doesn't change anything, right? So it's so simple that you reach to a conclusion that IN is equal to 3.3 amperes and RN is equal to 6.67. But I wish to show you this example because in the previous class or else the Norton's theorem itself is nothing but a replacement or the substitution method for Thevenin's theorem, right? So we can come to say we can solve the problems when asked for Norton's theorem by converting them into equivalent circuits or Thevenin equivalent circuit, because once you convert this into a Thevenin's equivalent, from there we can easily convert into a Norton's equivalent circuit. Why? Because by using source transformation, that will be easy, right? Suppose if this is a Thevenin's equivalent circuit which I found, that is, what is this value? We consider this as VTH, right? And what's the value I consider this as RTH, right? So now if at all I can find a VTH and RTH for elements for a circuit, then isn't that easy for us to convert that into a current source then?
Yes, sir. You can find ITH and then you can connect RTH in parallel.
Yeah, simply we can convert that into IN and RTH, right? So same value will become in parallel here. The value of V by R, that is VTH by RTH, I can write as IN, right? So when you are having complexity with the circuits, right? When you can't solve it for short circuited currents, right? So best method is to not directly go for finding a Norton's equivalent circuit components, but to find Thevenin's equivalent first. So for this circuit, we can apply the same principle, and first thing what we can do is to find the value of VTH. We solved a similar problem for this, right? We found some voltage drop across these two terminals, X and Y, and we made some statements in the previous examples for Thevenin's, right? We also solved a bridge problem as well, Maxwell's bridge, right? Or Wheatstone bridge, right? Have we solved the problem for Thevenin's theorem? Example problem.
Sir,
Yeah, we found these values, right? Vxy or Vab, whatever the values we assume, right? So it is easy to find the value of Vxy, and it's also easy to find the value of RTH. So based on them, we can calculate the value of, say, Thevenin's. We can find the Thevenin's equivalent circuit, right? So what you have, what is done here is to find the value of VTH. It is 22 volts, right? And we also found the value. We can also find the value of RTH by shorting them. We get the value of 6.67, and we can first draw the Thevenin's equivalent circuit here. Once Thevenin equivalent circuit is found, we can find the value of IN by short circuit X and Y. There you can find the value of current as 3.3 amperes, and you can draw the equivalent circuit like this. When will we choose this type of method, or when can we choose this type of procedure? Is when it is not possible, or when the calculation becomes complex for directly finding the value of short circuit current in solving the circuits. Am I clear? Is that okay?
Yes, sir, it is.
Yeah. So when it's not always possible, in some cases, this is not a complex example, but in general, when you come across some such type of problems, right? You just apply the same procedure, convert that into Thevenin's equivalent, and then to Norton's. That will be fine. Is that okay? So please, can you solve this problem using Norton's theorem? Example number 3, you just go through this. Using Norton's theorem, calculate the current in 5 ohms resistor, this resistor. So follow any of the procedure to find the value of Norton's equivalent circuit. Or else I want the current that is flowing through this circuit. Use whatever the method you want to use. You just find the value of current flowing in this. Okay. So tell me the values. Calculate the values of IN and I, or else get me the value of I first. So for that you need to get the value of IN and RN, right? So what is the first procedure, first step to find current in this resistor using Norton's theorem?
to find Rn.
Yeah, to find RN, what is the first step? We need to remove this 5 ohms, right? From 34.
Yes, sir.
What should be done now? We assume this as
We
A
need to short
terminal.
5 ohm resistance.
No. First we need to remove this, right?
Yes, sir.
First we remove this. We give this terminal A. This as terminal B, right? Now for this circuit, what is the first thing we need to find is short circuit current, right? So once I short this, there will be no current flowing in this. The current flowing here will become 0.
N0,
I will become 0 in this circuit, right?
N0,
Yes or no?
N0. N0 present,
Yes, sir. It
Yeah, so we can ignore this circuit, right?
2,
So once I have a short here, only thing I need to find is here, the current flowing here, right?
N4,
Is that okay?
5,
The current flowing here, you can consider it as I2. And what's the, if I calculate the value of I1, the same current will be assumed to flow through this short circuit, right? We already studied that current through a
Sir,
short circuit.
4.8 ohms, sir. I got.
What, RN?
Yes, sir.
P0,
Yeah, we can. Okay, keep it aside. Just get me the value of current first, because we are solving current, right? Yeah. Okay, we'll come to resistance later on. But what is the current we are going to get?
4,
We have to not consider the 6 and 4.
N4,
That's what I said, right? For
Yes, sir.
calculating
Yes, sir.
current, it is not required, right?
2 amperes.
Yeah, I mean, does it make? Do you people understand why we are ignoring the 6 and 4, right?
9,
Yes, sir.
Yeah. So this is shorted. So hence this is shorted. There is no current flowing in this component. So let me short this. Easy. Yeah. Now the only currents I have, the current divides only at this node, which is divided into I1 and I2, right? So what is the value of current I1 and what is the value of current I2 can be?
3, Q3,
So this I1 will be equal to IN, right?
Q4,
So what is the value of IN now?
5,
2 amperes.
How it will be 2, man?
8,
Current
8
will divide
amperes.
in equal parts, no, sir.
Yeah, current will be 8 amperes, right?
R0,
What's the current division rule, man? I1 is equal to total current into opposite branch resistance by total resistance. Isn't it?
Sir, why can't we take that the current will divide in equal
Which one?
R4,
10 amperes? No, sir. The
Yeah.
current will divide in equal of then 5 amperes from 2 ohms and 5 amperes from 8 ohms.
How is it that how is that possible that current divides equally with in unequal resistors? On what basis that divides equally, man? We have a current division rule, right? Rule states that the current flowing through any path will depend upon the value of resistance in the opposite branch, right? Suppose if they are not equal, if the current is to be equal, then the resistance are to be equal, right? There's only procedure. Isn't that right?
Yes, sir.
Yeah. So the current magnitude of current depends on the magnitude of resistance in the paths, right? So since the value of resistance is 2 ohms here, the current is 8 amps, and the value of resistance is 8 ohms, then the current is 2 amps. Is that fine?
Yes, sir.
So what's the value of Norton's current now?
8 amperes.
8 amperes. Let us give this as IN is equal to 8 amperes, right? What about the RN then?
It will be 1.6, sir, not 4.8.
Okay, IN is equal to 8 amperes, right? Right. So what about RN or RTH? What should be done first?
5 ohms.
This is open, right? This is open. So this is open circuited, no doubt. So has to flow, assume a current flowing in these two, right?
Yes, sir.
The current is coming here, it is dividing into two parts. So these two are said to be in series, these two are said to be in series. So what's the
5
equivalent you get? 5 ohms, right?
5 ohms.
What's the value you are going to get? 10 parallel with 10.
5 ohms, sir. 5 ohms.
So the value of Rn is 5 ohms. Now draw the equivalent circuit for that and get me the value of current I flowing through 5 ohms. So what's the value of current that is, what's the equation you write for current I flowing through load resistance 5 ohms? Can someone tell, draw the equivalent circuit?
For 8 ohm current source in
4
parallel with
amperes.
5, which is in parallel with load resistance.
Yeah. So 8
4
amp
amperes.
8 amperes of current source.
4
right?
amperes.
4 amperes. Yeah, current is 4, right? Okay. The current flowing through load is 4, right? I want the equivalent circuit, man. You can come to answers. You can get the answers anyhow, right? But we are interested in this drawing these circuits, right? So I have 8 ohms resistor with internal resistance 5 ohms. So this is RL. What is that? 5 ohms. And this is RN. That is also 5 ohms. And this is 8. So what's the current that flows in
4
IL?
amperes, sir.
Yeah. What's the equation I write here? IL as directly I write it as 4 amperes, or is there any equation for IL?
We can again use
Since
current
there are
division, sir.
same resistance,
apply
current
the-
will divide equal.
Yeah, I think you are satisfied with these values, right? The
Yes,
current
sir.
is dividing equal.
Yes, sir.
Fine. So justification is that since the values of resistors are same or equal, the current divides equally between them, right? So this is what we conclude for today's session. Fine. So I think we will be talking about network graphs and the second part of the unit 2 in the coming class. So I will share. I will try to share this PDF material related to this now. You can go through them, and you have we have many problems in that. You can use them, solve them. Okay. Just forwarding. Your rank, your okay. CSCIR official, right? Yeah. So I have forwarded the material as well. You just go through the say numerical tutorial problems as well. You have example problems as well as tutorial problems. You just go through them. Fine. And if at all, if I have any doubts, you can post in the group itself, right? We'll be discussing about problems later on as well. Is that okay? I'll take the attendance from the app itself. What's the next class for you? Python.
Python programming.
Yeah. 1 minute. Yeah. Let me wait till madam join the session, right? Okay, is that okay with theorems till now? You can you solve the tutorial problems in your? Shall I post some questions in the group or?
Yes, sir. You should. You
Sir,
could,
you
sir.
can post.
Yeah. So there are some some problems in the material itself which I have posted, right? So you just go through them. I will specify. Yeah, I will give some. I will mention some questions to solve, right? Which is already with you. I will just give the numbers, which will be say which are to be solved to analyze, which require some analysis as well, right? So I will choose some of them and I will post in the group itself. Okay, you try to solve them. Let us see what is the level of understanding you have on the theorems. Fine. So that's all for today. You just wait for the Python madam to join, right? Thank you, everyone.
Thank you, sir.
Thank you.